About 4 months ago, I bought a 3D scanner to go alongside my new 3D printer. I figured the technology for 3D printing had come so far, I thought scanners would do the same thing, and that you would be able to edit the scan file. In my head, the workflow was simple. You scan the part, you clean up the mesh a little bit, you throw it into the printer slicer, and then you hit print. You let the printer do its thing because the technology in the 3D printers has come so far, and boom, you got a replica. Technically, you can do that, but after spending the last few months actually reverse engineering automotive parts, I realized I had completely misunderstood what 3D scanners are actually good at, because the reality is, the scan is just the starting point. Most of the real work still happens inside CAD software such as Fusion 360, SketchUp, SolidWorks, all those, and that's something that almost nobody talks about online. Most videos stop at the cool scanning part. But once I started making my own parts that I wanted to use for myself and also eventually sell to people, I realized the scanner itself is actually the easy part of the whole process. The difficult part is taking messy real-world geometry and turning it into something that is actually manufacturable on the 3D printer, especially making final end product car parts. Because cars are complicated. We have heat to worry about, vibration, weird tolerances, we have mounting clips, organic or curved surfaces, material shrinkage as well, and there's all kinds of things that don't show up in those watch this guy do a cool scan on this really intricate piece, and then all of a sudden the next frame the part's completely done. That's why I'm making today's video, not to discuss whether scanners are good or bad, but mostly to discuss what they can and they can't do, and also stuff I wish someone told me before I had bought mine. Now with that being said, I don't regret buying my scanner at all. I've actually come to use it quite a bit in my workflow process when I'm designing new parts. But if I'm designing or just recreating like a simple radiator bracket, I just bypass the scanner altogether because it's actually faster just to use the good old digital calipers and some measuring techniques, and you just put it into CAD directly. You don't have to use the scanner at all for this. Granted, people have been doing this for a long time and been making very clever ways on how to scan a real-world object using real scanners or just photos or just sitting there and measuring everything and then putting it into the computer to remake it. Yeah, people have been recreating stuff on the computer since the dawn of computers, basically. So the scanner is just a very accelerated tool where it's taking a three-dimensional photo. And the way it works for my workflow and for automotive stuff is incredible. It also changed how fast I'm able to make parts, because there are some surfaces I would have no idea how to even begin to recreate within Fusion 360. Especially curvatures of items, and even some automotive parts aren't perfectly flat. Some of them have like a round edge and then they curve in the other way. I'm going to show you some examples of where this scanner was essential to recreating the part. And then we'll show you the goods and the bad. So here we are on the webcam. Before we jump into the computer, I wanted to thank today's sponsor, which is you guys. So if you guys enjoyed the video, please give it a like, leave a comment if this video was helpful, and share it along. So with that being said, I appreciate you guys watching, and if you made it this far, and we will keep going with the video. Alright, so here we are in this Revo Point. Oh yeah, I guess I haven't mentioned it at all in this video. I have a Revo Point 3D scanner. Revo Point Metro X is the 3D scanner that I bought. Here we are in this software, and here's the piece that I 3D printed earlier in the video. There are some people that are very good at 3D scanning, and they are able to get the perfect 3D scan, and you are technically able to scan it and print it. However, doing it is incredibly difficult, and I will touch on those points in the end of this video. That will be in the section right after this. So this is the first part that I scanned with my 3D scanner, and this is for a retaining clip for the mirror on my 240SX, my S14, and essentially I needed to scan this so I could design a hook to put my quick release steering wheel on there, but this was the beginning of it. So this is the scan. As you can see, it's not perfect. There's like a little blob right here. It didn't pick up this area too well. Something happened in the scan here. But the important part is the geometry reference. If you guys don't remember anything else from this video, just remember that the 3D scanner is needed for geometry reference. What we can do is I created this piece in the 3D scanner software, and now I'm going to import it into Fusion 360. So we're going to jump into Fusion 360, and this is what it looks like once it's imported. I'm not going to spend this whole video showing you guys the basics of Fusion 360. Just know that this 3D scanner accelerated my learning curve with it really fast. But there's no hiding the fact that I had to sit here and trace the whole thing out. And this is where the scan that we took comes in incredibly handy. This is the reference geometry. This is your reference geometry, is the scan. And I sat here and I traced this whole thing out. This isn't even the biggest thing that I've sat and traced out. This one was pretty quick by comparison for a lot of the other things that I've done. Now, important thing to note when you're 3D scanning a car part, they do injection molding. So you don't need to copy this stuff in here. This is like irrelevant to you. Like, I didn't sit here and trace this out. There's no need for it. You look at the part and you see what's important, and that's what you aim for. So I needed to keep the retaining clip section on the inside, the holes, and the overall shape. And then we were able to design it. So here we are with the final part. So someone came to me and asked me if we could scan and reverse engineer these lights because it was hitting the back of their bash bar on their car for their turn signals. So this is the S13 OEM turn signals. So this sits in the front bumper and at the bottom, and this is where the turn signal goes. Look how big this item is. The bash bar was hitting right here. He installed it and it was hitting right here. So in order for this thing to sit all the way flush in there, the bolts mount up here and the bumper's right here where it mounts. You would have to cut this whole thing out and then find a way to seal it up. And this project was a bit more challenging than I thought. But again, this is something that I wouldn't know how to do unless I had the scanner. For example, here, this is the big one. Curvature here, and you would think this part here is flat and this is flat, but it's not. So we're going to go to Fusion 360 and I'm going to show you what I had to do and what it ended up looking like. Here is version 1 of this product, and it was pretty bad, my pretty bad attempt. But this is where I made a few mistakes, and I'm going to show you guys my mistakes. I made the mistake of being very OEM and trying to copy the OEM light one for one when I didn't have to do that at all. Here, I copied the grooving on the inside, but I didn't get it too well, at least to my liking. And then I found out later that the mounting holes here, although I got the angles right, the car, when we went to go test fit this piece, it was too big and it was hitting the back side of this. So that means we needed to get rid of it and make it as flat as this piece for the outside. Again, Nissan was way smarter than I was, and they thought all this through. I went back to the drawing board and I had to tell myself, keep it simple. So I went over here, and this is the final version and what we got out of it. So now we have a very slim product, and again we have the angles correct. And the other thing to look at here, the biggest part that caught me off guard was see how these parts are like curved inwards like this. What you need to do is, in these 3D softwares, you have to kind of think outside the box. How can you get a curvature like this when you create it, it's flat? I'll show you what I mean. See this? So keep this part in mind right here. See this face right here? See how it's kind of angled up that way? This is what I learned during this project. Here I kept it flat, and that's why it wouldn't fit in the bumper at all, because when I went to remake this version, I kept this part flat for a little bit, and when I went to go retest it again, it still didn't fit. And I go, what is going on? And that's when I realized, wait a second, the OEM body is curved right here. It angles upwards. It's not a flat surface. It's not 90 degrees. It's curved up. So that was a big, like, oh my gosh moment. So now what do? Created this, and this was my extrude cut. Yep, and that right there solved every single problem. So overall, this whole process took about a week and a half from from him from him getting to my friend's garage, me scanning it, me coming home, testing it. I printed this piece about 5 or 6 times. He only saw 3 copies of it. My 2 other ones were just miserable fails. And then the final product that he finally got, and they're going to be installed in his car soon. So, yes, very proud of this one. This one came out very good. Yeah, so at the end of the day, the most important thing with the 3D scanner is the reference mesh. So at the end of the day, you have 2 options. You can recreate the scan one for one, which I've done before, and you can either get your scan and edit it to what you want it to be. So that's the whole point of the 3D scanner. All right, so now we can talk about some of the things that I struggled with 3D scanning. So in this housing, the crevices, there's actually a crevice where a gasket goes right in here, but this whole material in here has been failed because I tried to recreate the inside portion of it. So that's where I decided I had to keep it simple. Sometimes it has trouble with black plastics and also reflective surfaces. You do have to buy a spray. There are cheaper ways of doing this. I just got this so I could test it one time and see how well it worked, and it does work. So this kind of dulls the surface and it helps the scanner pick it up and be able to scan. The other thing with the scanner that's extremely tedious is this. But if you're scanning a big object, like a big plastic shroud or something like that, you need to put these markers on it, on the object. And if it takes you 30 minutes to put them on, it's going to take you about 45 minutes to take them off. And they're sticky, so they work well, but man, is it tedious to take them off once you're done scanning. So another bad thing about scanning that a lot of people don't show you online. And the last thing is definitely the setup time of the scanner. I know nowadays they have like all-in-one items that you can buy, like all-in-one scanners. I don't know how I trust those in particular because I have a pretty powerful computer and it kind of struggles even then to run it. So I don't know how much I trust a box like this big to take scans that are accurate. I'm sure they're great. I'm sure they probably get the job done. Again, I can only review and based on what I've been able to experience with these scanners. But it's a lot of setup time. You have to, depending on the item, if it's a car that you're scanning, you got to prep it. You got to make the surface clean. If it's an engine bay, sometimes you can just scan it and see what it gives you. If you're scanning a small part, you do have to prep the area. Trackers, you have to use stickers, you have to use spray. All in all, a scan job from start to finish can take you an hour or 2 hours to do from start to finish. And that's only the scanning part. That's not going onto the computer and cleaning up all the noise and stuff around. So just something to keep in mind of. This is still very time consuming, but it's part of a much bigger workflow. And it's only the beginning of the workflow. The longest part is definitely the CAD reverse engineering. And then the other part is figuring out how to print it reliably on your 3D printer, which could be a whole separate video. In the beginning, I did not have a good idea on how this would even work. 10 years ago, I tried to learn CAD and I just got frustrated at it and I just didn't pick it up ever again. And then it wasn't until I saw where 3D printing was going recently where I was like, I need to pick up a 3D printer and I have to get good at CAD. And here we are. But I thought the scanner would be a shortcut to CAD. I thought I would be able to scan it and then be able to edit that scan, which that's not the reality. The reality is you use the scan as a really good reference source and you recreate it by yourself in CAD. So yeah, that's the whole point of the video. So to summarize all this, do I regret buying my 3D scanner? Not at all. It's just part of a much bigger workflow, and it just took me a while to come to that realization that it's part of something much bigger overall, and especially when it comes to manufacturing. The biggest thing is being able to capture real-world geometry and being able to transfer that into the computer quickly. Just being able to trace everything and recreate it speeds up the process incredibly quick. The biggest thing I learned is that the scanner isn't the magic part, it's just a tool. The magic is still CAD, so you still have to sit there and figure out how to recreate something on the computer, and then not only that, have the ability to Think about material that you're going to end up using. You can't print this stuff in PLA. Think about vibrations. Think about the environment it's going to be in. Think about user error. The way I install it might be completely different to how someone else installs it. Some people are more rough. Some people are more gentle with their stuff. You got to account for all that stuff when you're designing. And also expect things not to work the first time around. One part took me, I think, like 4 or 5 or 6 prints before I finally came to the conclusion, and then I printed it one more time, so 7 in total, before I realized, okay, this is the final piece. So just be prepared for iteration. That's part of engineering. I don't know who lives in a world, at least engineers at least, where the first time they do something, it's perfect. Not in anything I've done at work has ever been perfect the first time around. We usually have revisions before the final one goes out. So if you're thinking about getting a 3D scanner for automotive parts, just be aware that it's part of a much bigger workflow. The scanner is an incredibly powerful tool, but it's just something that you put into the whole process of idea, scan, CAD, and then print. And then revision until you get something that you want. And once I finally understood that part of it, everything just started to make sense with CAD, and I've been able to just do a lot more stuff what I wish I was able to do 10 years ago. So I wish the technology was where we were 10 years ago, because I would have gone down that rabbit hole much sooner. But here we are now. So hopefully you guys enjoyed today's video, and I'll see you guys next time.